is a method of solving problems that involves breaking a problem down into smaller and smaller problems until you get a small enough problem that it can be solved trivially. Recursion usually involves a function calling itself.
Recursion consists of two parts. First part is base case. It is a part that makes a function calling itself. The second part is recursive call. It is a part that keeps calling itself. Moreover, it has to change its state and move toward base case.
Factorial. N factorial or n fact is a product of positive integer less than or equal n. Next is algorithm for factorial. If we want to find n fact, then we get n to this factorial function. Then we check that if n equals 0, then we return 1. Else, we return n multiply its function by sending n minus 1 to factorial function. This part is recursive call because it will keep calling itself. And n equals 0, then return 1 is base case. This will stop calling this function. Example, if we want to find 5 fact, start from 5 fact equal 5 times 4 fact. Then we don't know 4 fact, but we know 4 fact equal 4 times 3 fact. And then we know t fact equals t times 2 fact. 2 facts equal 2 times 1 fact. 1 fact equal 1 times 0 fact. Now we know 0 fact, that is equal 1, that is base case. And then we know 1 fact equal 1, 2 fact equal 2, 3 fact equal 6, 4 fact equal 24, and finally 5 fact equal 120.
Fibonacci number sequence. It starts from 0 term until n term. Next, I will show you the algorithm for calculating the n term. Start from the function Fibo. We get the value n. If n equals 0, we will return 0. Else if n equals 1, we will return 1. Else, we return the function n minus 1 plus function Fibo n minus 2. It will keep call its function itself until n equals 0 or n equals 1. These two are base cases. For example, we want to find the fifth term. The fifth term equals the fourth plus the third term. Now we don't know the value of the fourth term yet, then we recall its function to find the fourth term. The fourth term equals the third plus the second term. And we don't know the third and the second term yet, then we call its function again. Now we here to the third term. The third term equals the second term plus the first term. We know only the first term that it equals 1. Then we call its function again. The second term equals the first plus the 0 term. Now we get the value for the second term is 1. Then we get the value of the third term that 1 plus 1 equals 2. Then the fourth term equals 3 and the last one, fifth term, equals 5. And now we get the value for the fifth term is 5.
Recursion for the tree traversals. We can use recursion to traverse the tree in 3 ways. That is, in order, p-order, and post order. Example for the tree given by this graph. In order traversals, this traversal we will check the ref branch first. If we don't have the ref branch, we will print that node, and if the left branch is not known, we will call it function to check again to find the node that is known. Pre-order traversals. This traverse is going to start at the root or the word CPE, and then traverse to the left branch. We will print the node that we visit. Then check that left child is null or not. If it's not, call the on function to check again. The last traversal is post order. This traversal we will check the left branch, then check the right branch. If both of them is null, we will print it out. If both of them is not null or one of them is not null, we will call it function to searching the node that null. This process we will call recursion because it calls itself to continue doing something.